All right, so we were on example 4. We're just going to do a couple more examples of breaking down the rules of exponents and using them so that we can simplify an expression. You don't need to give one like decimal answer. You're just making it simpler, okay? So again, we always end with positive exponents. So 3/5 to the power of -2 is going to be 3 to the power of -2 over 5 to the power of -2, right? So what I did is I distributed that -2 to the top and to the bottom of the fraction. No problem. Thank you. I see your message. And then, right, it says positive exponents only. I know how to change a positive exponent to a negative exponent. It is take that base and the exponent and move it across the fraction bar. So we're going to do that for the 3 and we're going to do it for the 5 because those are both negative exponents. So the 5 to the power of -2 on the bottom becomes 5 to the power of +2 on the top. The 3 to the power of -2 on the top becomes 3 to the power of +2 on the bottom. Then I'm just going to write what 5 squared is. 5 squared is 25. 3 squared is 9, right? If it were possible to divide 25 by 9 or to divide 25 and 9 both by a number such as 5 or 3, I would do that. But they do not have any common factors, so there is no way to further simplify this. Good? All right, same thing we did on step 2 of this one. We're going to do for the first step of this one. This is just 6 to the power of -2 times x to the power of -4 times y to the power of 10 over y to the power of 2 times, x to the power of 2 times y to the power of -6. So I'm just going to take all my bases that have negative exponents and I'm going to move them. That's all we're doing here. Remember, if you had something such as y x to the 4th over 5 squared, or -4th, sorry, that would make more sense. You're only applying that -4 to the first number, okay? Even if y doesn't have an exponent, the exponent of y is 1. The exponent of y is not -4 unless those are parentheses, okay? So, are in parentheses. So y times x to the -4 over 5 squared becomes y to the 4th, x to the 4th, 5 squared. But, so this is just a random example, just in case anybody's. This one, we're going to move both of them. This one, we're just moving the x. It's okay that y is up here alone without any exponents, okay? It only applies to the leftmost term unless there are parentheses. Oh, there's a question. If you move an exponent to the denominator, do I combine it because the sign has changed? Yes, yes. Down here, like the x and the x. You can combine them. Yes, good question. You can combine them whether the signs are negative or positive. So if you, this is a great question. So if you had x squared times x to the -4th over y to the 3rd, you can combine those right now. So remember, when you're multiplying exponents, you're just adding. So that becomes x to the -2 over y to the 3rd, right? And then you'll move the x down. But right now you have x to the -4th. So you're going to move it and then you're going to combine it with the 2. Or you can combine them before you move them if you want. So actually, I'll show you 2 different ways to do it. Whichever way makes more sense to you, choose that way, okay? So we're going to move everything. All that's left on the top is a y to the 10, right? 6 to the -2 becomes 6 to the +2. X to the -4th becomes x to the 4th. So now I've covered 6, x, and y on the top. Now let's go down to the bottom. X squared, y to the -6, we're actually moving up here. So that becomes y to the 6th. Now we're going to combine them, okay? So this is one way to do it. I moved it first, now I'm combining. 10 plus 6, they're all positive, so that's just y to the 16th. 6 squared is just 36, because 6 times 6 is 36. X to the 4th times x squared is just x to the 4 plus 2, which is x to the 6. Okay, so that's one way to get your final answer. No way to simplify it further because you have different terms. 36 can't combine with x can't combine with y can't combine with 36. Or I'm going to rewrite that. 6 to the negative 2, x to the negative 4, y to the 10th over x squared, y to the negative 6. So if this way does not make sense to you, that's okay. We're going to end up with the same answer as we ended up with here. But remember, the rule for exponents, the one we've already used, is a to the power of m times a to the power of n equals a to the power of m plus n, right? Another rule, the second rule we learned, was a to the power of m over or divided by a to the power of n is a to the power of m minus n, right? So we can use that rule even with negatives. There's nothing to combine with the 6. There's no other base that is the same as 6. So 6 to the negative 2 gets left alone. But x to the negative 4th can be x to the negative 4th, according to this rule, minus 2, right? Let me show you what I did. I used this rule to combine these two on the top, okay? And then I'll use that same rule to say y to the power of 10 minus a negative 6. Now, there is no more fraction, right? They all ended up on top. This was on the top to begin with. This we subtracted because we were dividing, and this we subtracted because we were dividing. Now let's simplify. That's still 6 to the negative 2. Negative 4 minus 2 is just going to be x to the negative 6. But 10 minus negative 6 is actually 10 plus 6. So I'll write it again. 6 to the negative 2, x to the negative 6, y to the 16th. And now you can start moving them. Okay, so we just switched the order. Here we moved them and then combined them. Here we're combining them and then we're moving them. So I'm going to move my 6 and I'm going to move my x because they both have negative exponents. And what I get is y to the 16th on top, 6 to the positive 2 times x to the 6th, which is the same thing I get here. So you can combine them whenever you want. If, remember, the only rule is if the base is the same. If they have the same base, you can combine them at any time. Here, we're going to distribute the negative 2, and we can probably combine the b's, right? Because there are b's that are common to the top and to the bottom. All right, 4 gets raised to the power of negative 2. A to the 3rd gets raised to the power of negative 2. B squared gets raised to the power of negative 2. On the bottom, b to the negative 6 gets raised to the negative 2, and c gets raised to the negative 2. Okay. Now, before I do any moving, I want to simplify a power raised to a power. So that's the first thing I'm going to do. 4 to the power of negative 2, a to the power of 3 times negative 2, right? And then b to the power of 2 times negative 2. Okay. Thought that was all one page, but it's 2 pages. Ran out of room. And then b to the power of negative 6 times negative 2, and c to the power of negative 2. So that'll still be 4 to the negative 2. A, 3 times a negative 2 is a negative 6. 2 times a negative 2 is b to the negative 4th. On the bottom, we have a b to the negative 6 times negative 2 becomes a positive 12. And c is just left with a negative 2. Now you are the same place we were over here, where you can either move them first or you can combine them first. Here we combined them first, here we moved them first. You get the same answer either way. think it's a little bit easier to combine them because then you have all positive exponents, but whatever you think. And it kind of depends on the situation as well. No worries. All right, so this one is going down. A is also going down because it's a negative. And oh, everything on top is going to the bottom of the fraction. And then the C is going up. Okay, write it in whatever order you want. Just don't forget any pieces. 4 to the negative 2 becomes 4 to the positive 2 on the bottom. A to the negative 6 becomes A to the positive 6 on the bottom. B to the negative 4th becomes B to the 4th on the bottom. B12 stays on the bottom. Out of room though. And then C squared moves. So now all I have on the top is C squared. On the bottom, I have 4 squared, which is 16. A to the 6th, and then I'm combining B to the 12th times B to the 4th. Remember, our rule for multiplication is we just add them. So that becomes C squared over 16A to the 6th, B to the 12 plus 4, C squared over 16A to the 6th, B to the 16th.
Can you move that down just a little bit? I can't.
I do that all day. Thank you. And we would have gotten the same answer if we had started combining up here. A minus 6, or sorry, A to the power of negative 6, I guess we would have just had to move. B to the power of negative 4th would be to the power of negative 4 minus 12, right? And then we
So
would
it's, sorry.
No, go ahead.
So it's simplified that way then?
Yeah, you can simplify it this way where we moved them all, or you can simplify it by subtracting negatives if you're comfortable.
So the answer that we just got is the simplified form?
Yes. Simplified form basically means there are no negative exponents. If you have numbers, the numbers are in the lowest terms, and then you don't have like the same letter on top and on the bottom, because you want all your bases combined. So you started with 2 B's, a B on the top and a B on the bottom, or you could start with an X on the top, X on the bottom, Y on the top, Y on the bottom, or even 2 right next to each other, and they just want you to put those all together. Good question. All right, here we're just, again, distributing the negative 2 to everything. So it's going to be 3 to the power of negative 2 to the power of negative 2, A to the 3rd to the power of negative 2, B to the power of negative 2, C to the negative 4th to the power of negative 2, A to the 7th to the power of negative 2, and B to the negative 3rd to the power of negative 2. Just distributing that negative 2. So what you'll get is 3 negative 2 times negative 2, A to the 3rd to the power of negative 2, B to the power of negative 2 over 3 to the negative 4th to the negative 2, A to the 7th to the negative 2, and B to the negative 3rd to the negative 2. I wouldn't combine them until I'm done with this multiplication here. So the first step is always distribute the exponent, and then you can make your choices of what you want to do next. So that becomes 3 negative 2 times negative 2 is my exponent for 3. My exponent for A is 3 times negative 2. My exponent for B is negative 2. Don't keep going. On the bottom, 3 to the negative 4th times negative 2. A to the power of 7 times negative 2. B to the power of negative 3 times negative 2. Now you're just doing that math. Bases stay the same. 3 to the power of 4. A to the power of negative 6. B remains negative 2. Here we have a negative 4 times a negative 2, so we get a positive 8. Here we have, oh, sorry. Yeah, it is a negative 2. Here we have a 7 times a -2, so that's a -14. And then here we have 2 negatives, which make a positive, so it's b to the 6. So at this point, you can either say 3 to the 4 minus, sorry, 8. 3 to the power of 4 minus 8 times a to the power of -6 minus -14 times b to the power of -2 times, or sorry, -6. Or you can move these. So that was the 3, because that's the same base, different exponents. And then we have our a, looks like that. And then we have our b, looks like that. You're going to get the correct answer. Okay. And so that answer would be 3 to the -4, right? Because 4 minus 8 is -4. A to the -6 plus 14, right?
I have a question.
Mm-hmm.
So why is like word and it's saying like b to the exponent -2 minus 6? Wouldn't it be +6 since the bottom one is b6 and that's a positive?
Good question. The rule is if they are already side by side, you're adding them. But if they're on different sides of the fraction bar, you're actually dividing them. And so when you divide exponents, you subtract them.
Oh, okay, that makes sense. Okay.
That was a good question.
Yeah,
though.
I wasn't here for that part. So okay, that makes
Ooh,
sense.
That takes a lot. I'm proud of you. I would have tuned out. Good job. All right. So 4 and 8 were both positive, but since they're across the division bar, we're subtracting. -6 minus -4. I just want to make sure. Yep. Okay. Yeah. Okay. -6 and -4, but we're subtracting them. So when you subtract a negative, you end up adding it. And then we have b, -2 minus 6 is just, you're combining them as though you were adding. And so 6 plus 2 is 8, right? But they were both negative, so it's actually a -8. Now, one more time, 3 to the -4, a to the, what's 14 minus 6? 8. And then b to the -8. Last thing we're going to do is now we still have to move them. Turns out, after all that, you still have to move it. So we're moving that one down and we're moving that one down because they've remained negative. Final answer is a to the power of 8 over 3 to the power of 4 times b to the power of 8. And then you're actually, I said that was the final answer, but it's not. You need to take that 3 to the 4th and just put it into a whole number, 81. So we have a to the 8th over 81 b to the 8th. Okay, so that was immediately subtracting using the subtraction rule. So again, if anybody else, because I know other people are wondering, if anybody else is wondering why we're subtracting, a to the m over a to the n means you subtract n. This is vertical. Also, if it's horizontal, a to the m divided by a to the n, same thing. M minus n. Good. So that's the rule we used. Here, we're going to use a different rule first, and then we're going to come back to that rule. Okay. So the other rule that we're going to use is a to the power of -n is equal to 1 over a to the power of +n. So that's the other rule you can use. Okay. That means if any of these are negative, you can move them right now and make the exponent positive. Don't worry about the base being negative, only worry about the exponent being negative, okay? So we're only looking for negative exponents, not negative bases. We don't need to move either of those are positive. So we have 3 to the 4th A to the negative 6 is going to go on the bottom, become positive 6. B to the negative 2 is going to go on the bottom. It's going to be a positive 2. Go down to the bottom. 3 to the 8th doesn't need to move. A to the negative 14th needs to move. So A to the 14th comes up here. B to the 6th does not need to move. So here's an example of now they're right next to each other. That rule is if they are next to each other, we can just add them together because that's multiplication. Division, subtract, addition, add. Okay. So that becomes 3 to the 4th, A to the 14th over 3 to the 8th, A to the 6th, B to the 8th. Oops, I'm sorry. Good. And we're doing so this is going to be the exact same answer as the blue color. It's just a different order you went in. Okay. Now we're going to use the rule of subtraction. If it's being divided, we're going to subtract it. So we have 3 to the power of 4 minus 8, A to the power of 14 minus 6 over, there's no B's left, so we're just going to leave the B on the bottom. B to the 8th. That means we get a 3 to the power of negative 4, and we get an A to the power of 8. So you're kind of seeing a pattern over B to the power of 8. Now we do need to move the 3, the bottom, so that it's a positive 4. So our final answer is 3, positive 4, sorry, I got ahead of myself, over times B to the 8th over A to the 8th. And that 3 to the 4th is actually 81. So you end up with the same answer.
Your paper is so colorful right now.
Thanks. Hopefully it
There's
helps.
so much going on.
Hopefully it helps, but I don't think it does. I think I just get I overuse the colors. It's supposed to highlight things, but I just overuse them.
It actually helps me see the numbers better. So
Okay, good. I want to get better at like knowing what I'm doing with the, thank you. Knowing what I'm doing with the colors.
It
So
keeps
whichever,
it from blending together as much. Like I can actually see what you're doing instead of it all just looking like the same thing and then getting lost.
thanks. Yeah, it's less
Yeah,
depressing, right? It's less
definitely helps me.
okay,
I have
good.
dyslexia, so
Now she's holding a black pen. All right, try to keep up. Yeah, it's a lot, but I want to make math a little bit less bad. Thanks, guys. All right, example 6. We're gonna keep going. Don't worry. Yeah. And if you need more examples, you can ask for work and with the answers, or you can ask for me to make videos of certain equations, certain problems on my math lab, whatever you need, okay? All right, so here we have x to the power of negative b times, right? So this is all just a multiplication. We're basically saying x times negative b. This is still multiplication because it's next to parentheses, but there are parentheses because we're going to distribute that positive 2. So now we have x to the power of negative b times 2 to the power of 2, because that was a positive 2, times x, and that was a b, 2 plus, oh no, sorry, it's times 2 times b. It would be plus if it was x to the b times x to the squared, but it's x to the b raised to the power of 2. Good. All right, so that becomes x to the negative b times 2 to the power of 2 is just 4. And then x to the power of 2 times b is just x to b. Okay. Now, can you combine negative b and 2b? They have the same
I want to
base.
say no.
What's the rule? It's a good question. I mean, I don't know. The rule is if our bases are the same, right? If I had xm times xn, I say x to the power of m plus n. Right? Oh, sorry, that n is way too big. I started staring off into space. So the base is the same, right? So can we add those? If our base is the same and they're each being multiplied to something, we can add what's being multiplied. So let's try it. I did want to say no too, though. So we have x, and we have, I'm just going to take the positive and put it first. So we have this is our m and this is our n, right? So we have 2b plus negative b. For x, 2b plus negative b is just 2b minus b. What happens if you have 2b and you're taking away one of the b's? You just have b, right? 4x b. So I did want to say no also, but it's actually yes, because the bases, the only rule is, are the bases the same? If the bases are the same, you can put them together, and then it might just be a strange subtraction in the exponent, and that's fine. Or you can say those are actually like terms. That's a 2b and that's a 1b. So I'll just take one of the b's away and get 4x to the power of b. Here's another way to do it. X to the negative b times 2 squared times x to b, right? Becomes 4 times x to b times x to the negative b. You think, oh, that's a negative exponent. I'm going to move it down. That's also fine. Now you have 4x2b over xb because it goes from a negative b to a positive b. But you can keep going. x2b, what's the rule for when we're dividing? You just subtract. So there are two different ways to get to it. But either way, it's 4x to the power of b. Good. All right. Y to the power of 3a to the power of 2, y to the power of a minus 6. I think it was supposed to, I think we were supposed to do the 2 for everything. I think I wrote it wrong, but let's just keep it to this. We've done enough of this, right? So we just have one base to this power. And then when you have x to the power of m raised to n, you're multiplying them, right? You've seen me make that mistake right here. I added them instead of multiplying. You're multiplying them. So it's 3a times 2 over, and there's nothing to distribute here, a minus 6. Good. 3a minus 2 is just 6a. Here we have a minus 6. Good. Same, again, same base. Our rule is that I'm going to subtract them. Oh yeah, I am sorry. Monday's lecture is not on Blackboard yet. I apologize. 6a minus a minus 6. So we took this exponent and subtracted this exponent no matter what it is, even if it's long. Okay. Y 6a minus a minus 6. So I'm going to distribute that negative sign. Becomes a negative a plus 6. Is that okay? All right. So 6a minus a is just 5a plus 6. So this is all your exponent. Didn't make that clear. Small 5a plus 6. Don't worry, nothing like that will be on the exam. Oh my goodness, I'm spending all of today still doing yesterday's or Monday's lesson. I apologize. All right, when you multiply, I appreciate how much you guys are reaching out though. All right, so multiplying in scientific notation. When you're in scientific notation, I know this is a switch and we put them together because scientific notation uses exponents, but it is definitely a shift. So now in the last 15 minutes of class, we're going to shift over to scientific notation. Remember, it's a decimal number with one digit in front of the decimal point and then something raised to the multiplied by 10 raised to a power. Okay. We practiced that in 5.1. Now we're going to multiply in scientific notation. Ready? Remember, when you are moving right, it is negative. And when you are moving the decimal point left, it is positive. Oh, that's the long word. Positive, like in the middle. I think I got it. Negative has a G, right has a G. Positive has a T, left has a T. Okay. So let me give you an example because I didn't provide any on this page. For example, 2 times 10 to the 4th times 3 times 10 to the 3rd. Right? So those are actually big numbers because 10 to the 4th is, you can put it in your calculator, 10,000. Good. So we're multiplying 2 by 10,000. We get 20,000, right? So we're saying 20,000 times 3,000, right? It says multiply the decimal numbers. That's the 2 and the 3. So 2 times 3 becomes 6. And then add the exponents of 10. So just like the rule for adding exponent or for combining exponents that you're multiplying, if you're multiplying exponents, you're multiplying the same base with different exponents, you're adding the exponents. All right. So 2 times 3 is 6. And then 4 plus 3 is 7. Or probably makes more sense to say 10 to the 4th times 10 to the 3rd is 10 to the 4 plus 3, which is 10 to the 7th. Okay. So that's all on the exponent side. This is on the decimal side. So what you end up with is, instead of a 2 or a 3, you have a 6. And instead of 10 to the 4th or 10 to the 3rd, you have 10 to the 7th. Good. All right, let's make it a little bit harder. 2.1 times 10 to the negative 3rd times 2.798 times 10 to the negative 9. Good. So the first thing you're going to do is multiply the decimal numbers. 2.1 times 2.798 becomes 5.8758. Sorry, just trying to make sure you know that that's what we're doing. You don't need the brackets. Just wanted to make sure that that's the purple part. We took those two. We got 5.8, 5.9, I guess it's closer to. And then we're going to take 10 to the negative third times 10 to the negative ninth. And again, we're just using the rule 10m times 10n equals 10m plus n, regardless of whether they're negative or positive, okay? Which is the exact same rule as x to the power of m times x to the power of n equals x to the power of m plus n. If you have the same base, you can add them. Go ahead.
So it would be 10 to the 12th power?
Yes, negative or positive?
Positive because it's two negatives.
No, because you're just adding them.
They would, yeah, you're right. Sorry.
And no, it's a good point because it brings up the fact that you are welcome. You have to leave scientific notation negative. Okay, so 10 to the negative third times 10 to the negative ninth is 10 to the power of negative 3 plus negative 9, which you said was negative 12. So our final answer is 5.8758 times 10 to the negative 12. And you just leave it just like that. One more. We'll do 4.2 times 10 to the fourth times 2.9 times 10 to the ninth. Good. So we are going to multiply 4.2 times 2.9. Sorry, 4.2 times 2.9. Oh, that was a terrible job of putting in the decimals. All right, put that into your calculator. 4.2 times 2.9 is 12.18. Ooh, not. No longer in, that's okay. No longer in scientific notation, unfortunately, but we can keep going. So that was those two. Now we will take 10 to the fourth times 10 to the ninth, right? It becomes 10 to the power of 4 plus 9, which is 10 to the 13th. Good. All right. Now you have 12.18 times 11, sorry, 10, I'm confused the matter, 10 to the power of 13. But this is no longer in scientific notation. So 12.18, I need to move the decimal over to the left one digit, right? So that it becomes 1.218. If I move it to the left, I need to multiply it by 10 to the power of the number of places I moved it. How many places did I move it? I moved it one place to the left. So it's a positive 1. Let's just check it. 1.218 times 10 to the power of 1 is 12.18. Okay. 1.218 times 10 to the power of negative 1 would have moved the decimal point in the other direction. So if you ever need a reminder and you don't remember and you have a calculator, you can just test it with a 1 or a negative 1, see which direction it's moving. So that became this. So that it was actually in scientific notation, but we still have to multiply it by 10 to the 13th. So now that's 1.218 times 10 to the first times 10 to the 13th, and that's okay because we know the rule that if the bases are the same, I add these exponents. That becomes 1.218 times 10 to the 14th, because 10 to the first times 10 to the 13th is 10 to the 14th. All right, I think we can get through division. So for dividing, we divide the decimal numbers and subtract the exponents. Just like here, 10m times the power of 10 to the n equals 10 to the power of m plus n. Here, we subtract the exponents because 10 to the power of m over 10 to the power of n is 10 to the power of m minus n. Good. All right. 9 times 10 to the 8th over 3 times 10 to the 5th is. Good. We're going to divide the decimals. So just take 9 divided by 3. Hopefully you get an easy number. 9 divided by 3 is 3. Sorry. 9 divided by 3 is 3. Subtract the exponents. So 10 to the 8th minus, or sorry, divided by 10 to the 5th is the same as 10 to the power of 8 minus 5. So I'm dividing the bases with different exponents. And the way that I divide the bases with different exponents is I keep the base, subtract the exponents, 10 to the 3rd. So I get 3 times 10 to the 3rd. Ooh, that's broken. Do it again. 6 times 10 to the negative 2nd over 5 times 10 to the negative 6th. Again, we are just dividing. 6 divided by 5 is 1.2. It's okay if it's a decimal, of course. So we got 1.2 when we divided by 6 divided by 5. And then we're going to take 10 to the negative 2 divided by 10 to the negative 6 is 10 to the negative 2 minus negative 6, right? Subtract the exponents. Negative minus a negative 6 is a negative 2 plus 6, which is 10 to the 4th. So I got 1.2 times 10 to the 4th. I'll do 7.8 times 10 to the 4th over 8 times 10. Okay. 8 times 10 is the same as 10 to the power of 1, right? 8 times 10 is the same as 8 times 10 to the power of 1. You get the same answer. So 7.8 divided by 8. I can just put it into my calculator. 7.8 divided by 8 is 0.975. That becomes that, which becomes 0.975. 10 to the 4th divided by 10, which is just 10 to the 1, is 10 to the power of 4 minus 1, right? 4 minus 1 is 3. However, again, this is an answer and it's not wrong, but it's also not in scientific notation because it doesn't have a single digit in front of the decimal like this one does. So we need to take 0.975, move the decimal right here so that we have 9.75. So if I move the decimal right, it's negative, right? Because if I think of the word right, it shares the G with negative. So 4.75 times 10 to the negative 1 was that. And then we're going to multiply it by that original 10 to the 3rd. So now that's 9.75 times 10 to the negative 1st times 10 to the 3rd. If they have the same base, but and we're multiplying them, then we just add the exponents. 9.75 times 10, negative 1 plus 3, 9.75 times 10 to the 2nd. Good. Sorry, guys, right down to the wire, and we didn't even get to 5.3. Don't worry, I will change due dates. Everything else goes faster. Exponent notation and, or sorry, scientific notation and exponents require a lot of detail. Thank you all for asking questions. You are welcome to go.